Welcome to Click for IB Biology. We're studying D4.3 climate change. And in this particular video, we're going to be looking at the anthropomorphic effects which have led to global warming. There's a blank PDF of this presentation that's linked into the description below. You can download that and annotate with your own notes. And then when complete, why not take the 10-question quiz which will evaluate your understanding of this part of the course. The answers are, of course, provided for your assessment. The major contributors to anthropogenic causes of climate change are those which include the processes that increase carbon dioxide in the atmosphere and those processes which increase methane in the atmosphere. Two of the major greenhouse gases students may wish to link to topic C4.2, which also considered these effects. And of course, those major carbon dioxide contributors are the combustion of fossil fuels, often from industrial sources, but of course also from domestic use, including of course our vehicles and our transport. Contributing to a change in the carbon dioxide levels in the atmosphere, of course, is deforestation. And then we also have this contribution from what is called embodied carbon sources, which includes the construction industry with its use of calcium carbonate and calcium oxide, particularly in the use of materials such as construction concrete. So those are just a few of the carbon dioxide contributors. On the side of the methane contributors, we have farming practices, agricultural farming practices, such as can be seen in rice farming, with the methane production from the anaerobic conditions of the soils here. There's the decomposition in this area here of waste from human processes, and then also the venting of gases in the oil industry, in which there's a release of gases such as methanes, and they're burning off into the atmosphere, where such gases are seen as waste products. So these contribute to the changes in the atmospheric carbon dioxide levels. And if we focus in on fossil fuels as representative of the major contributors, we know that this diagram is relating to the extra carbon dioxide production, that 45% of that extra carbon dioxide production ends up in the atmosphere. And of course, this is where we refer to the greenhouse gases, and in turn, this will lead to the greenhouse effect, which you can also review in C4.2. Our oceans assist us greatly by absorbing estimated round about 27% of our extra carbon dioxide production, but however, this does lead to negative effects such as in the acidification of oceans, and we'll take a look at those concepts later on. And before we move away from this diagram, the growth of forests, terrestrial plants, is thought to currently reduce the extra carbon dioxide by about 27%, but these trends are changing as these biomes are modifying as a result of the global warming effects. The studies which are attempting to obtain data to support these ideas come, of course, famously from the measuring of the atmospheric carbon dioxide levels by Charles David Keeling, which began in the 1960s, leading to the construction of the famous Keeling curve, which again is dealt with in C4.2. Well worth taking a look at those videos and that part of your textbook. And Keeling, Charles David Keeling, monitored the atmospheric levels, finding this general upward trend here this data which supports the idea of there being an increase in carbon dioxide levels within the atmosphere. Keeling's work is supported and also elaborated upon by studies which take place in our polar regions, and particularly with respect to the Antarctic region, as shown here. And most famously are the Law Dome ice cores. The Law Dome is this large glacial buildup, as shown in the diagram here, and it's possible for us to extract deep cores from the ice, and the significance of these cores is that they date back hundreds of thousands of years, and these samples allow us to sample at various levels along the ice core. We can extract information about the atmospheric composition of gases at those particular times, and you can see the carbon dioxide levels are being shown here below in this particular graph. And the significance of this graph, of course, is this sudden inflection in the levels here, which coincides with anthropomorphic effects, anthropogenic effects rather. This huge increase in the atmospheric carbon dioxide levels, certainly over these time periods here, like so. Those ice cores are based on what are called air age, in which, as the snow forms, gases within the snow form bubbles, and the gas within that bubble is representative of the age at which that bubble was formed, and this is called air age. And you can see here the data showing the fluctuation, but the sudden inflection which coincides with human activity, and particularly, of course, industrialization. The data that we are collecting can be found from a number of different sources, and you can see in this graph I've plotted against time. We have carbon dioxide levels in the atmosphere, but then on this side we also have the changes in the atmospheric temperatures compared to a baseline beginning back here in the 1960s. And so we see a correlation between time and carbon dioxide levels as the increase in this positive correlation, and also we can see the similar pattern in the temperature changes. And so we speculate whether or not these two factors can be combined together in a causal relationship between carbon dioxide levels in the atmosphere creating increases in carbon dioxide temperature levels, like so. And of course, with such data, it's possible for us to statistically analyze these trends and patterns by calculating correlation coefficients and evaluating the strength of those, and also by determining how well the data fits those by looking at factors such as R squared, the coefficient rather of determination, two different measures of the data. The question, though, as to whether the carbon dioxide levels are bringing about the changes in the temperature levels are based on what are called attribution studies. And these are the mechanisms by which increases in atmospheric greenhouse gases leading to increases in global temperatures result in temperature changes, and then the impact that they will have on the environment. Those causation studies and those global impacts are the subject of the videos which you are now about to see, and as are linked in here on the left hand side, with a chance to subscribe to the channel, always greatly appreciated. The playlist is on the right hand side for your convenience.